Venn diagram. So basically, what is the represent of the set in a Venn diagram? We start with the example. So we consider the universal set U. So U we consider for the particular example universal set is 1 to 10, and also we consider the two another set capital A is a 2, 4, 6, 8 and B is a 1, 3, 5, 7. So all these three set how to represent in a Venn diagram. So obviously U is the universal set. Now a capital A is the set 2, 4, 6, 8. We write in a circle. Another set is B 1, 3, 5, 7, and the universal set U is a whole 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. But 9 and 10 is not involved in the set A and set B. In set A only 2, 4, 6, 8, set B 1, 3, 5, 7, and the universal set is involved all the elements 1 to 10. So what is the meaning of the Venn diagram? So diagrammatically representation of sets is known as the Venn diagram. A British mathematician John Venn introduced the concept of diagram to represent a set. Basically, universal set is represented by the interior of the rectangle. So universal set is always represented in the rectangle form, interior in the rectangle form, and the other set are represented by the interior of the circles. So U is a universal set and we represent in a rectangle form. A and B is the other set we represent in the circle. So this is the total whole concept of the three set U, A and B in this representation, which is called a Venn diagram. And using this Venn diagram, we seen that a set A and the set B are a subset of the universal set U. Or also we seen that A and B has no common element. So obviously we can say both are the disjoint set, because we know that the disjoint set, that means A and B are no common element. We discussed in the earlier lecture. So now the another concept of the set, difference of the set. How to define the difference between two sets. So let us consider with the example, we consider the two set P is a 2, 3, 4, 5, 6 and Q is a 4, 5, 6, 7. So what is the meaning of the difference of the two sets? So a new set having those elements which are in P but not in a Q, which are in a P but not in a Q, is said to be the difference between P and Q. And it is denoted by the symbol P minus Q, because we know that the difference symbol is the minus. So for particular example P and Q, we write P minus Q. P minus Q. So obviously 4, 5, 6 is same element in a P and Q, but 2 and 3 is only for P, not in Q. So P minus Q is a 2 and 3. Similarly, 4, 5, 6 is a similar element in a P and Q, but 7 is not in a P. So therefore Q minus P is equal to 7. Now a whole concept how to represent in a Venn diagram. So consider the universal set U. Now this set is capital A, sorry P. Another set is a Q. So green circle is a set P, yellow circle is a set Q, and this blue is the intersection between P and Q. So now the remaining part of the green portion is said to be a P minus Q, and the remaining a yellow part is a Q minus P. So this portion, yellow portion is a Q minus P, green portion is a P minus Q, and this portion is nothing but the intersection P and Q. And here observe P intersection Q not equal to 0. And when P intersection Q not equal to 0, then we can say both are not disjoint. So when P and Q are not disjoint set, then the representation of the difference between P and Q2 set is using the Venn diagram is this. Similarly, we consider the another universal set U. Now this is P, this is Q. So here whole portion of green, because in this figure this portion blue is a intersection region. So except this intersection region we consider P minus Q, but here intersection is equal to 5, no intersection point, so the P is indirectly P minus Q. Similarly, Q is also a Q minus P, but when this is possible, when P is a P minus Q and Q is a Q minus P, if P and Q are disjoint set. So disjoint, that means no intersection point. Now the another concept of the set is a complementary set. So what is the definition of the complement of the set? So if U is the universal set, U is the universal set and A is the subset. U is the universal set and A is the subset, then the complement of A is a set of those elements which are in U but not in A, which are in U but not in a A, and it is denoted by A dash or A complement. So we write A raised to C is indirectly A complement or A dash. So again the complement of the set, that means we consider the universal set U. Also we consider the another set A which is a subset of U. Then the complement is defined of those elements which are in U but not in A. So in a set builder form we write A dash, yeah, A complement is a U minus A, and which is represent X such that X belongs to U but not X does not belongs to A. Those element which is belongs to you but not belongs to A. Now the complement of the set can be represented using the Venn diagram as, suppose this is the universal set U. Now another set which is a subset of U, we consider capital A. So obviously the green portion is indirectly a complement, or a complement, that means A dash or A complement. So this green portion, whole green portion, which is represented by a complement, because uh, all element which is in U but not in A. Now next, the union of sets. So if A and B are any two set, then union of A and B is the set of those elements which belongs to A or B. It is denoted by A union B. So this is the symbol of union. So A union B, that means those element which is belongs to A or B. But if we write A union B, then we consider only one time which is common in A and B both. In the set builder form, we write A union B. A union B is X, which X belongs to A or X belongs to B. A union B can be represented using the Venn diagram as, suppose this one is the universal set U, this is a capital A, this one is capital B, and both are not a disjoint set, so obviously this one is A intersection B. So now whole blue form, whole blue region, this one, whole blue region is indirectly the A union B. So the whole region is A union B. And another concept, when both are disjoint, so A, set A, now another set B, so A union B is a whole region of A and B. As for example, verbally, suppose A is a 1, 2, 3, and A is a 1, 2, 3, A is 1, 2, 3, and B, another set B is equal to 1, 3, 5, 1, 4, 5. So what is the A union B? So A union B, we write A union B, we write one is the common element, so we write only one time. 2 is not a common element, so 2. 3 is not a common element, so 3. Then 4 and 5. So A union B is 1, 2, 3, 4 and 5. So this is a concept of the union of two sets. So now, okay, the another concept, how to define the number of the element of A union B. So the formula for the number of element of A union B is nothing but the number of A plus number of B, number of A plus number of B minus number of A intersection B, minus number of A intersection B. So if given that number of A is a 5, number of B element is a 6, and number of A intersection B is a 2, and we want to find the number of A union B, so easily we write 5 plus 6 minus 2, that means 11 minus 2 is equal to 9. And using this formula, we find the different value. As for example, if A union B, number of A union B is given, number of A is given, number of B is given, then we find number of A intersection B. That means a total 4 term, 3 term is given, then easily the remaining term we find. So now we stop here today lecture. Thank you very much. In the next lecture,